postdoc at Southern Illinois University, Edwardsville, and I work for a project called CosmoQuest. I'm going to tell you a little bit about that. It is a citizen science initiative and astronomy education portal online. And so what we're trying to do is get science data in the hands of people, the general public, and have them actually participate in the process of science. And so I think this connects with the theme of this conference in that there are a lot of conflicts in the way that people view science. And this is one way that we think we can get people to actually participate and hands-on and get involved in the process and see what it's all about. So citizen science is a long and storied history that I don't have time to get into, unfortunately, but I will tell you that one of the driving factors for citizen science is that we are building bigger and bigger telescopes. So I've got two examples here: the Large Synoptic Survey Telescope, which will be coming online in the coming decade. And this is going to survey the entire sky every few nights. And so they're getting terabytes and terabytes of data. And the artist's conception of what the square kilometer array will look like, which is a large telescope that's being built in Australia and South Africa. And I worked for a project for my dissertation here called PAPER, which is maybe 1% the scale of this telescope, and we're bringing in, we're filling up 8 terabyte disks in the course of a month and a half. So it's kind of staggering the amount of data that we'll be getting from all richness in the universe. And we actually need people to come and look at this data and come help us out, because we don't have enough eyes to actually look at all of this. So this is in the coming decades, these staggering amounts of data. But it's already starting with a few NASA missions that we've partnered with. So the Lunar Reconnaissance Orbiter is a nice, pretty artist conceptions of what these spacecraft might look like hanging out around their targets. The Lunar Reconnaissance Orbiter is orbiting the moon, taking very, very high-resolution images of the surface of the moon, mapping the entire moon. Like, we can see this is the first instrument that let us see the footprints of the Apollo astronauts across the surface of the moon in the regolith. These are incredibly detailed maps. And the Dawn mission, which spent a little over a year orbiting asteroid Vesta. So Vesta is the second largest asteroid in the solar system. And it collected data, high-resolution maps of the surface, and it just left Vesta, but the science is really just getting started. They have all of this data to process. A couple of other missions we've partnered with are New Horizons, which is on its way out to Pluto, the formerly known as planet Pluto, a dwarf planet, whatever you want to call it. It's scientifically interesting, so we're going with that. But after the rendezvous with Pluto, we want to they have enough fuel to make one more course correction and visit another icy big Kuiper Belt object, but we don't know which one yet. And so we're using very large ground-based telescopes to search for this object that New Horizons will visit. And the ever iconic Hubble Space Telescope, which 20 years later is still making important discoveries. So all of these NASA missions we've partnered with that we can take their data and bring it down to people and have them help us out. So the first project we're launching is Moon Mappers, and this is using the Lunar Reconnaissance Orbiter data. And when you tell people we're having people mark craters on the surface, most people will say, well, can't you have an algorithm do that? Can't you have a computer program do that? And you can to a certain extent. So this is an example of one of our tasks on the website. And this is an image where the algorithm has already gone and marked all the craters it thinks it can find. And it's only about 70% accurate. It hasn't marked anything that's not a crater, that I can tell. But it's missing these craters that are not as well defined, these highly eroded craters that are very important for understanding surface history. So we have people come in and they're like, well, you missed that one because it's a lighter colored terrain and the algorithm managed to miss that. You missed that one. Last check, we're up to almost 800,000 craters have been marked, and we're aiming for 1 million, and so that's been a very popular project. We just launched Asteroid Mappers. So it's a similar crater marking task with these very different, very bizarre images. And the days leading up to the launch of this. I got so distracted looking at all these pictures of Vesta and marking craters because I had access to the server and it wasn't public yet. And I had to stop myself because we need to leave this for the people to do. But you have again a highly cratered terrain, these huge craters. There are linear features and ridges and boulders and all of this weird stuff that we haven't seen before we got to Vesta, where we haven't really explored these smaller scale objects in the solar system with such high resolution. So again, we have people coming in and joining asteroid mappers and doing science on that. We briefly, let's say we have a project called Ice Investigators, but we had a project called Ice Investigators. This is looking for those Kuiper Belt objects for New Horizons. We have images where most of the objects have been subtracted, these ground-based images, and users can spot the little candidates for these Kuiper Belt objects through the different images. And I say had because it was so popular that all our users went through all of our images in the span of like 3 weeks. And they're actually having issues with the telescopes. So they haven't sent us any new images yet. So we're waiting on that. And then coming down the pipeline, we have planet investigators, Jupiter and Saturn, Hubble images that we'll be able to look through and spot transient cloud features. And then we'll have a Mercury planet mappers as well. So we have all this data coming down the pipeline from NASA that people are using and helping us do science. But that's not what we want to do. We're actually trying to keep people engaged and build a community around learning science. So this is introducing science to people who may have last taken a science class in high school or college 20, 30 years ago and thought, oh, this is cool, but it's not for me. Astronomy is kind of like a gateway drug to science because everyone goes, oh, black holes, I've heard of that, I want to check that out. So we're doing a fairly ambitious project in an environment that is somewhat hostile. The internet can be a scary place, I will admit sometimes, and there have been a lot of conflicts in the science community over issues like climate change, over topics like evolution, and even people who are all on board with the science. There are conflicts about sexism and racism, and a lot of vitriol happening within these communities on the internet. And so we're trying to step in and say, hey, we can get past this a little bit, get past this hatred, and get past these conflicts, and actually do something that is helping out the science, and something that we can all agree on. It's not very, it's not much up for discussion, like, ooh, craters, you don't see people getting in major arguments over that. We just subsumed the Bad Astronomy Universe Today forums recently, so we've collected those communities together. Phil Wade, who was here last night, and Fraser King graciously gave us their community to help us work on CosmoQuest. So we have forums, we have educator resources. So Cosmo Academy is our educator resources. We're working to put together lesson plans for teachers to bring into the school, to bring citizen science to their students. We've started piloting online classes so that anyone who wants to learn about astronomy more in depth can come take these classes using Google Hangout technology. And I want to show you another kind of community building exercise, something where people are coming together over the science, but not just coming together over facts and data, but actually touching people emotionally with the science using these Hangouts on Air. So Google Plus launched a little over a year ago now, and one of the things that they featured was this video Hangout technology, this video chat technology, which was fairly stable, having used several different types of video chats in the past. You can have a lot of issues, but fairly stable, and now allows you to broadcast to anyone. So we do these Hangouts on Air where you can fit up to 10 people in the video chat and broadcast that to the world and show them, it started off as I think there was a commercial recently on TV that Google's put out saying, well, people started just chatting, and then they started having concerts and talks and doing all these things. So they actually came and did a little mini documentary about the virtual star party, which is one type of hangout that we do, in addition to just talks and discussion. And so it was literally this idea that Fraser had, because he just has these crazy, brilliant ideas sometimes. Like, what if we hook up a telescope to a webcam and just broadcast what we're looking at live? And it grew into this amazing network of amateur astronomers that set up their telescopes in different time zones. People come in. We usually do them on Sunday nights, but we also do special events like the Transit of Venus. And we had, we're sitting there with our webcams and our laptops, broadcasting to the world. We had 6,000 viewers at any given time, and it's just this amazing democratization of media and technology that we've been able to reach people. So this is something that I'm really excited about, because we can use science, but actually touch people emotionally and reach people across the world. Anyone with an internet connection can come on in and be a part of the science, be a part of the discovery, learn about science, and just help us explore the universe. So that's kind of our motto is, what would you like to explore today? So if you can, check us out on CosmoQuest and be a part of the science, be a part of the community.